Hello, fifth graders. So we are going to start looking at day and night, okay? So this is going to be kind of a little bit of a long investigation. I might cut it up in my videos depending on how this flows, but we're just going to start right now just investigating day and night, okay? So what I want you to think about is our focus question, which is, what causes day and night? Now, we did investigate this a little bit at the beginning of the year, and we're going to go into it a little bit further now. So, what causes day and night? So let's think about it. What is night and what causes it? So I want you to think for a minute, what is night and what causes it? Okay. So there are some things, you know it's night when it's dark, right? When the sun goes down, that's some thoughts that some of you might have. When the sun's on the other side of the earth. Let me see here. Oh, when it spins and we can't see the sun, then we know it's night. And then let's think about this. What causes day? And how do we know it's day? So think for a minute. Okay, so we know it's day when it's light out, when the sun comes up, and when the sun is on the side of the earth, that is light. So now, I have a lamp right here, and this is going to be, if we turn it on, ooh, it's bright. This is going to be our sun, okay? And we're going to look at this, and we're going to look at the globe, and we're going to kind of investigate how day and night works, okay? As it's going around the globe. So I'm going to position the lamp here, and I'm going to hold the globe in front of it. So let's see, I'm going to put the United States right here, okay? You guys see that? That's the United States, the yellow portion, and we're going to hold it there. When we're looking at the yellow portion is facing the lamp, and that means in the United States it is day. It's like right smack dab in the middle of the day. And if you're looking at the middle of the state, it's actually noon, because when the sun is directly in the very top of the sky, that means it's noon. And if you go over to the other side of the globe, on this side, it's experiencing midnight. Okay? 12 noon, midnight. Okay, so here's what I want you to think about. When an object turns or spins around like a top, we refer to that motion as a rotation. So that's what our globe does. It spins around in a rotation. An imaginary shaft on which the object turns is called an axis. So I have a stick in here. This is my axis. The earth doesn't have a stick. It just is, it's an invisible thing that the earth rotates on, and that is called its axis. Earth rotates on its axis and runs the axis that runs from the North Pole to the South Pole. So here's the North Pole, and it comes out the bottom on the South Pole. So let me see. So let me put my little guy on here. I'm going to set him right here. Okay? He's my little guy. And I'm going to turn it so that he is experiencing sunrise. So that means when the sun's just coming up, and you're going to watch his face. Let me get him. And I'm going to turn it slowly. I'm going to turn it slowly. I'm going to turn it slowly. So now he's experiencing sunrise because he's just hitting the sun. The sun is just hitting him, right? So that's sunrise. So the point between light and darkness and day is daylight. Okay, so that point between night, darkness, and daylight, that's the time when the day first happens, okay? So now we're going to look at sunset. So we're going to look at the back of him, okay? And as soon as that sun stops shining on him, oh, there it goes. It's starting to, okay? That is sunset. The point between day and daylight and night and darkness. That time at which night first happens. So it's like right when that change happens, okay? So we're going to keep doing this, okay? Okay, so let's look. So I want you to look at where my little guy is. Is it day or night where he is? I want you to think. Is it day or night? Okay, so it's daylight because he's right in the middle of the sunlight, right? Now I'm going to rotate him. I'm going to rotate him around. And now what is it, day or night? It's actually night, right? Because he's on the other side of the earth. What did I do to cause the change from day or night? So let's think, what am I doing? What's happening? The earth is rotating. That's how we know the change between day and night. So we demonstrated how rotation causes change between darkness and daylight. The earth rotates causing different parts of the earth's surface to be in daylight and darkness. But I have one more question. Which way does the earth rotate? Okay, so which way does the earth rotate? So let me see. So this is New York, this is California where I have the guy. It rotates in this direction. So the sun always rises in the east and sets in the west. So this is the rotation that it takes. It goes counterclockwise. Okay. As you might know, the sun rises at a different time across the United States. The sun rises on the East Coast first, and slowly sunrise sweeps across the country. 3 hours after the sun rises in Washington, D.C., it finally rises in California on the West Coast. This information might help you determine which way the earth turns on its axis. When the sunrise occurs on the East Coast, it is still dark out west. 3 hours later, the sunrise happens on the West Coast, so kind of like I showed you. So, we're looking here, okay? The sun is rising on the East Coast, and here's my little guy on the West Coast. It takes 3 hours. Now I'm doing it a little faster for it to get to our little guy there, okay? So it doesn't rise in the United States at the same time. It rises within a difference, right? Within a different amount of time. It takes a little bit longer for it to get over there. But it's still, let's see. So when it's sun rising here in the West Coast, what is it on the East Coast? Just think about that for a minute. It's still daylight. It's almost noon probably, or not noon, probably about between 10 and 11. So yeah, almost noon. When it's rising on the East Coast, what is it over here? When it's just rising, it's kind of hard because, there we go. It's still night, right? Sorry, I have to kind of keep referring back because it's not ingrained in my brain yet. So I'm going to put sunrise in New York, which is right here, and I'm going to hold it up, right? It's right there. So it's sunrise in New York. When it's sunrise in New York, is it day or night in California? So if it's sunrising here in New York, is it day or night over here? It's actually night. So now I'm going to turn it so the sunrise in California. When it sunrises in California, is it day or night in New York? So we kind of talked about that, right? So now it's sunrising in California, and it's still day in New York, right? It's more towards the middle of the day in New York. So now we're going to make it so it's day, like straight day in both New York and California. So now remember, the earth rotates counterclockwise. okay? And it rises in the east and sets in the west. Okay, we're gonna keep going. So the top here is the North Pole, right? So if you're looking, this is the North Pole. It's sunrise right about here on the globe. If you turn just a little bit further left, the sunrise will happen a little further on the globe. So now in India, it's starting to sunrise. And in China, the sun is starting to rise. If you continue to rotate, pretty soon it will be noon and in China, and a little while longer it will be afternoon. So let's look at our guide, okay? So let's go here. Let me make sure he's on there. Okay, so we're gonna do sunrise. So now it's just rising on him. As we rotate it, now it's kind of afternoon. And as you keep rotating, the day keeps progressing, and eventually it will be sunset. So as he rotates, it's sunset. If you keep rotating in the same direction, it's going to be dark, and we're gonna have the whole night. So now he's in the dark, so everybody should be sleeping. We'll put him down. He's sleeping, okay? And then as we keep going, he's gonna wake up soon, so I'm gonna put him up. It's going to be sunrise again, so that's 24 hours. So from this point, as we rotate around, I'm gonna do it a little faster. That's a whole day, and it's 24 hours is how long it takes for the Earth to rotate all the way around. Okay. So there's some questions that I'm not going to ask because I already kind of answered it, and I think it's kind of silly for me to ask it again if you're not here to answer it and show me that you know, right? So what makes the sun rise and set? Let's think about that. What is it that makes the sun rise and set? Okay, what makes the sun rise and set is the Earth's rotation on its axis. Does the sun rise in the morning all over the world? Think about that. Is it rising all over the world in the morning? Is the sun rising? No, right? Because exactly half the world is in light and half the world is in dark. So it depends, the sunrise depends on where the Earth is rotating, okay? So the sun is a star positioned at the center of the solar system that gives off light continuously. The sun is a source of light that illuminates the Earth's surface. So this is the center of our atmosphere, and it's a star, and it lights up the Earth. When the light falls on an object, the object illuminated, the area behind the object is in the shadow in the dark. So here's the shadow, here's the light. When the light falls on a spherical is the Earth, it's a ball, object, like a planet, exactly half is illuminated. The other half is in the shadow, which is dark. The dark side of the sphere is its own shadow, not the shadow of another object. So this back here is the shadow of the sphere. Day and night are names given to the light and dark halves of the planet. Day, night. From our position on Earth, it looks as though the sun circles the Earth once every day, but in reality, the sun is stationary, essentially, and the Earth rotates on its axis once every day, giving the appearance that the sun rises and sets. One complete rotation of the planet describes one complete day. For Earth, one rotation requires 24 hours or 1 day. So remember, it goes around, that's 1 day. Okay? If the planet did not rotate, would it have day and night just the same as on a planet that rotates? Okay, so that's kind of funny. So yes, if it didn't rotate, it would have day and night, but the only thing is, the difference is that when a planet rotates, the part of the planet experiencing day and the part of the planet experiencing night changes continually. If a planet were not moving or rotating, each half of the planet would experience day for half a year and night for the other half. And here's the reason. Because not only does the sun or the earth rotate like this, it also goes around, okay? It actually rotates around the sun. So it would just take longer for day and night to happen, okay? So now, here's what we're going to look at. Revolution is different than rotation. Rotation means turning around on an axis like a top. Revolution means traveling around something else, like a race horse running around the center of a racetrack in a circular path, for instance. Planets, including Earth, revolve around the sun. Earth rotates on its axis and revolves around the sun. So this is a revolution as it goes around the sun, which you can't see the whole thing, but you can see part of it, okay? And this is a rotation, and it's actually doing it all together. And that's why the sun rises and sets at different times during the year, because of the revolution around the world. That's why we have winter, spring, summer, and fall, because it depends on how far, because we're at an angle, how far away from the sun we are on our tilt, if that makes sense, okay? So people often think the Earth revolves in an oval or elliptical path as it orbits the sun. In fact, the Earth's orbit around the sun is nearly circular. So some people think it's like an oval, but actually it's nearly completely circular. There's a star in the night side called Polaris, or the North Star. It is positioned directly over the Earth's North Pole. The Earth's North Pole always points towards the North Star. Summer, fall, winter, spring, day and night. That's why the North Star has been a navigation aid to seafarers and explorers in the Northern Hemisphere for centuries. In our Earth-Sun system, we need a North Star. You will have to visualize the North Star through here, right? Way off in the distance. The North Pole of our model, North Pole, will always point towards north, to the North Star, as it revolves around the sun in its orbit. So we can use the star up here to approximate where north is, okay? So we go like this, the North Star is up here. As it rotates, it's always facing the top or towards the north, if that makes sense, okay? We're gonna keep going. Okay, good. So here's a couple things I want you to know. Rotation is when it spins on its axis like a top, okay? Revolution is when it goes around, okay? And that's what causes the different season. The North Star is like right here. It's always facing north no matter how the Earth is and as it goes around, okay? And what we're gonna do after this is we are going to read a story, or it's gonna read an article to you, which is called, let me find it real quick, Sunrise and Sunset, and it's gonna explain sunrise and sunset a little bit further. And what I want you to do is I want you to answer the focus question, which I'm gonna put right over here. And our focus question, I'm gonna get back to it so we can, what causes day and night? So I want an answer to that, and I would love it if you could email it to me, okay? I love you and I miss you, and I hope you're having fun. Bye.